So we're going to look at how to analyze the slope and the y-intercept of a graph and what that can tell us about the phenomena we are observing. So I went ahead and put some data into Vernier graphical analysis, and I have a separate tutorial video on how to use graphical analysis, and I'm going to go through and analyze these data. So first, you'll notice that we're looking at time and temperature data. So as the time increases, what happens to the temperature? And the first piece of data I want to look at is the m. And we know that m is the slope. So first I'm looking at the slope. And if you remember, slope is calculated by rise over run, which is the change on your y-axis, divided by the change in your x-axis. So when we can actually figure out the units on our slope, we need to keep this in mind. Slope is rise over run. So in this case, m is negative 3.72, but we want to have units on that because otherwise it's negative 3.72 what? Elephants? Who knows? So let's figure out the units. So we need to look at the rise, that's the y, over the run, that's the x. So the units on my rise are degrees C. So my units over here will be degrees C over my run, where the units are seconds. So my units are rise over run. You need to look to the units on your graph to get that information. Now the next thing I would like to do is write a for every statement for this. And a for every statement always starts with, for every obviously, for every one, whatever is on your x. So time, for every 1 second increase in time. So I always start with my run. I'm always starting with my x, my run. The temperature, that's my y, my rise, my dependent variable. So for every one change in my independent variable, my temperature, my dependent variable, if I look at the slope, I see it's negative. So that means it's decreasing. If it was positive, it would be increasing. Decreases by 3.72 degrees Celsius. And I'm almost done. So that's my basic for every statement just based on the slope. But if I look at my graph, I notice that this does not start at 0. And if I look at my b is 81.8. And again, since it is rise degrees Celsius, so anything that's a y-intercept, y is your rise, it's always going to be referring to degrees Celsius. So I would like to add to my for every statement starting at 81.8 degrees Celsius. So that's my whole for every statement. For every 1 second increase in time, the temperature decreases by 3.72 degrees Celsius, starting at 81.8 degrees C. And so the last thing I would like to do is write an equation for this line. So you probably remember from math class, the basic equation for a line is y equals mx plus b. And we're still going to hold that. We're just going to start replacing stuff. So instead of y, I'm going to write temperature, because that's what's on my y. Oops. And instead of m, I'm going to write in my actual m. So we have that m value right there. So I'm going to write that in. So 3.72, and I'm going to include units. Degrees Celsius for every second, times. The next thing we need is the x. And I'm going to just move this all over a little bit just so I have some space. So this is going to be times our x value, which is time. And then the last thing we need is this plus b. So once again, when I come over here, I see b is 81.8 degrees Celsius. So I'm going to add that there at the end. So you can see I just replaced each part of this equation with what it actually represents, whether that's a variable or a number. Y and x are variables, m and b are numbers. And now I have an equation that actually tells me something. It gives me some information that's going to be really helpful. And now I can make predictions based on that equation. All I need to do is plug in a temperature or plug in a time, and I can make a prediction based on the other one. So very easy, but lots of information comes from a graph.